Hello, and in today's lab activity, we are taking a field trip to Panama Canal and to Texas. But first, I'm going to demonstrate the first lab activity, which involves maritime monitoring map, and then the second will be a flooding map of Texas. So let's pretend for this scenario that you're an imagery analyst for the Panama Canal Authority. You must locate and monitor the ships waiting to sail passage through the Panama Canal. So let's navigate to the Panama Canal. And so today you're going to be changing the symbology of an analysis-ready SAR image, SAR, and assess the presence of ships in it. So I'm going to zoom in to the SAR data. So SAR, as you should know by now, because I talked about it in the lecture, and I included some videos from YouTube on this type of sensor and imagery. It's synthetic aperture radar satellite imagery, so it's different than what we've been working with so far in the class. So here we have our Panama Canal SAR imagery, and the first thing we're going to do is symbolize the imagery. So first you'll switch to the map for maritime monitoring map, and you should have already the Panama Canal.crf raster layer. And so like the images used in some of the examples that I gave in this week's lecture, this analysis-ready SAR image is derived from a SAR grid data product from ICEYE, ICEYE Satellite Mission. So you can get SAR satellite imagery data from a number of different public sources. Okay, so let's right-click on the layer and select Symbology. And in the Symbology pane for color scheme, we want to expand the drop-down. And we want it, well, first we want it to have stretch on it. And then for color scheme, let's expand the drop down. And then let's click Viridis. And I have to maybe navigate and scroll to it, but it starts out as purple, blue, and kind of goes to green. Right there. And you can also search for it, but I'm going to click that. And then you should see the layer update for this symbology. Okay, so let's interpret the data. The areas of the highest backscatter values appear in bright yellow. So we could see some bright yellow in the land and some out on the water. And the lowest backscatter values are in dark blue tones. The ocean appears in this dark blue and green tones, and the land appears in yellow and light green tones. In the ocean, the ships appear in bright yellow. And so because of the backscatter, you can see that the ships appear in this bright yellow. And sometimes they appear with not just oblong, like an oval, like the kind of image of a ship, but you'll also see like a plus sign or kind of like a star image on some of the ships. So yeah, that's kind of a star. So in this image, the highest backscatter values correspond to a type of scattering named double bounce, which I've gone over in the lecture. So in this type of scattering, the radar signal reflects once off a vertical target onto a smooth surface and reflects a second time off the smooth surface back toward the sensor. So this scattering type can take place on human-made structures such as ships and buildings. Okay, let's zoom in and find a boat that appears elongated yellow shapes. So like I've just zoomed in up here, but let's zoom into some of these. So these are all ships. And so because of the double bounce scattering effect, some can appear as bright plus signs or stars, which I've already gone over, but you can zoom in to a star kind of ship. So since ships give off double bounce scattering, the backscatter contains high values that can sometimes be interpreted as bright plus signs or stars. This represents a common image artifact intrinsic to SAR imaging. But it helps achieve the objective of the analysis, which is, can you see and count the ships? Okay, so that's it for the first scenario. We just wanted to do a basic symbology change, and then that highlights the high backscatter values. So if you chose this as your scenario for the lab activity, go ahead and insert a map frame, choose this as your map, and add the 5 essential map elements. Okay, let's go on to the second scenario for this week's lab activity. And for this week, we are going to take a field trip to Texas. And we are going to look at the effects of the hurricane from 2015. So we're going to be identifying areas flooded by Hurricane Harvey. I think that was in 2015 in the area of Freeport, Texas. So working with analysis-ready SAR images again, captured before and after the hurricane. So we have one before and one after image. We can learn more about polarization bands and derive 2 color composites. Then you'll use the swipe tool to visualize these flooded areas. So let's begin by looking at the symbology of these SAR images. Let's click the one that's after, so 2017-08-29. Oh, and sorry, I said 2015. Hurricane Harvey actually happened in 2017. Okay, so right-click on the layer and select symbology. And so you could tell that this is slightly different than the previous scenario in Panama. And you could see that the band selected is VV. And if you click the drop down, you also have the option of selecting VH, which I've gone over in the lecture. But the image is composed of 2 bands, VV and VH. A single SAR image can contain several bands, each band representing a different polarization of the radar wave. In this case, one band here is copolarized, VV, and the other one is cross-polarized, VH. Each band can highlight different features on the Earth's surface, so they all contain useful information. And so each of these bands can be visually separated, so you can view each band on the map. And so currently on the map, we're displaying the band VV. But now let's switch to VH. And so the map then updates, and you could see that VV and VH polarizations each highlight different elements of the landscape. So let's zoom in a little bit and go back to VV. And sometimes it's quicker if you turn off world imagery. So I'm going to select VV. And then let's switch to VH. And so we saw some subtle differences, but overall it's hard to distinguish between the 2 bands when we're symbolizing them individually. So it does work in some cases, but we can view each band independently, or we can combine them, which will create a richer view of the landscape, which is what we're going to do next. And so that will allow us to distinguish more clearly surface characteristics such as water, land, and urban areas, urban structures. Okay, so we can do that by creating a color composite in which each band will be assigned to the red, green, or blue display channels. Okay, so to do that, let's click out of symbology. And then on the ribbon, on the analysis tab, so analysis ribbon, let's go to geoprocessing group and click tools. And let's write create color composite. Okay, and then click the first one for data management. Oh, you know what? I'm sorry, click the second one for image analyst tools, not the first one, the second one. And on the parameters tab, we're going to select the after raster. So it's 0829 because that happened after. And then the tool automatically populates the remaining parameters, and then you will change some of these values as well. So for the output raster, verify that the value is to Texas underscore 2017-0829.crf. And then for output raster, oh, that was the input raster, sorry. For the output raster, verify that it's the same title as the above raster, but then underscore rgb.crf. And for the method, let's choose the drop down and select band names. For red expression, we're going to select VV, which is already there. And then for green expression, we'll do VH. And then for the blue expression, we want to erase the ending and type VV minus VH. Okay, so that was changed. It wasn't the default. This means that for each pixel in the image, the value for the VH band will be subtracted from the VV band. The result will act as a third band that will be displayed through the blue channel, and will further highlight interesting features for the landscape. Okay, let's select Run. And so the band math, while this is computing, the band math used depends on the units of your input SAR data. If your input SAR data is in decibels, the band combination must be VV for red, VH for green, and VV minus VH for blue. If your input SAR data is in linear units, use VV for red, VH for green, and VV backslash or divided sign for blue. Okay, so this is running. You could see it took, 30 seconds or more. And a new raster layer for the after image was made, and it appears on the map. And the color composite shows water bodies, oceans, rivers, and flooded areas in blue. So over here is obviously the Gulf, and then up here you could really see the flooded areas. And purple tones, vegetated and forested regions in green, and then urban structures in yellow. So right here, we zoom in, that's the most urban area. Oriented orthogonally to the radar look direction, which I discussed in the lecture. And then debris in the water or flooded vegetation is also kind of shown too in some pink and yellow hues. So now we will now create the color composite for the pre-hurricane. So that was for after. Now we're going to do the pre-SAR satellite image. So go back to the same one, create color composite. And this time we're going to select Texas 2017-0805. And then we will keep the default name. Band names, it should all be the same. Red expression is VV, green expression is VH, and blue expression is VV minus VH. And then select Run. So now we're going to compute the second raster that's showing the new color composite. And the next step is fine-tuning the symbology of these layers to make them more meaningful. Okay, so I'm waiting for this to load. Okay, so my second new raster layer has been created and added to the map, and let's toggle it on and off. Oh, and we can see pretty clearly the differences. So that's after the flood, and that's before the flood, and then after you could see the water, the flooding, which is the water, is in blue, and it's all over the Gulf Park area. As well as below this other stream. Okay, but we're going to change the symbology to emphasize some of these features. So currently the value ranges are different. For instance, you can see that the vegetated land displays in darker green in one image and lighter green in the other. See that? So we want to click the symbology for the after layer. So go to Texas 0829 and right click and select symbology. And then click the options button and choose import from layer. So that's the 3-bar menu in the top right. Import from layer, not import layer file, import from layer, this one, the second one. And then in the geoprocessing pane for the apply symbology from layer tool, choose the following parameters. So choose the 0829, so the default there. And then select the before, so Texas 2017-0805 underscore RGB. And then we're going to keep the default, which is maintain ranges. And then select run. So we're running the apply symbology from layer tool. So the two color composites are now using the same symbology with the same range values. For instance, the vegetated land displays roughly with the same light green tones. So next we will examine the imagery and interpret the data. So we've done this before, but let's close some of these. And we're going to use the swipe tool. So on the ribbon on the raster layer tab, in the compare group, select the swipe. And then on the map, grab the swipe handle so it appears when you hover over the map. And then drag repeatedly from top to bottom or side to side. Oh, and you have to make sure, sorry, the top one is selected. So I had the after photo, or after raster, and so you want the before selected. So now you can swipe and see the differences pretty clearly. So you take a second to observe the differences and identify the areas that have become flooded. Try to distinguish features that can be used as reference points. For instance, this stream or this road. See surrounding areas around that have been flooded. And you could see the areas that are submerged with water after the hurricane, or just purple indicating the presence of vegetation or debris in the flooded area. So that's either debris or more vegetation. And so when you are finished with the swipe tool, and exploring the images on the ribbon on the map tab, you can select the explore, and then be sure to save your product, your map and product. And if you chose this flooding map as your lab activity to submit, then insert a new map frame, new layout rather, and insert the correct map and add the 5 essential map elements. And make sure to zoom into the correct area. And you can add guides. You can feel free to stop this lab activity, but if you'd like to watch how I make a map, you can do that as well. I like to remove the reference data sources. So to do that, you select dynamic text, click service layer credits, and just put it off to the side. And of course, if you're publishing something or if it's going in a formal report, then keep it on, but cite the source of the data in a caption. And then I'm going to just show the after flood for this map. want to look up if I spell Hurricane Harvey correctly. I am, so that's good. And then I'll put the date. Okay. Sometimes I just want to start fresh with my scale bar, and that's totally fine. And then in the caption of where this would go in a report, I would describe what these colors meant. But for now, this is good. And then I'll just add the date and author that this was made. So let's do March 3rd, 2023, because I think that's the start of week 8. And then Noel Frempter. And let's not make it too big. Okay, and so then when you're ready to share, you could export layout to flattened PDF. You just need to save it somewhere on your disk and then keep everything default and then press export. And then that's where you will upload. You'll go and navigate to that file. So I'll do this now. Let's go to my Questa folder, week 8, and then I'll put flood map. Okay, save, export. And sometimes the export, oh, I spelled hurricane wrong. Okay, let's stop that. Always double check your map because you don't want to spell something wrong. That's very avoidable. So I'll just save over that. Okay, close that, and now we're going to navigate. Oh, that's my husband and I climbing. We're going to navigate to the week 8 and then check our flood map. Okay, and then it opened up and that looks good. Title, scale bar, north arrow, and that legend. Looks good. Title, and so then I would upload this to Canvas. You could submit this on Canvas under week 8 module, under lab and activity section, and then I will see you next week. Thanks.